Howdy. We are at, Life Science. Spectacular Butterfly Nebula offers a glimpse in our sun's final fate. Published 23 hours ago. New time-lapse images of the beautiful Butterfly Nebula come closer to explaining its spectacular strangeness. A color rendition of NGC 6302, the Butterfly Nebula, created from black and white exposures taken by the Hubble Space Telescope in 2019 and 20. In the violet-colored region, strong stellar winds are actively reshaping the nebular wings over the past 900 years. The other features range in age from 1,200 to 2,300 years. Maybe. Deep in the constellation Scorpius, a cosmic butterfly spreads its wings. Meet NGC 6302, an enormous shell of glowing gas pattern known as the Butterfly Nebula, located about 4,000 light-years from Earth. The double-winged nebula is a spectacular example of what happens when stars like the Sun run out of fuel and die. This is probably completely wrong. They don't die. Very often they have novas over and over again according to their own cycle. Hidden at the point where the two wings meet, once mighty star now smolders as a tiny collapsed white dwarf. The wings themselves are the remains of that star's outer layers of gas, which were expelled violently into space thousands of years ago when the star inevitably ran out of nuclear fuel to burn and died. Maybe not. But anyway. Today those wings span more than 3 light years or several thousand times wider than the solar system, according to NASA. For more than a century, astronomers have tried to understand why the Butterfly Nebula took on such a distinct insectile shape, while most other nebulas expand into space in neater circular patterns. New timeless images of the nebula presented on January 12th on the 241st meeting of the American Astronomical Society in Seattle offer some fresh clues. And you can bet no one talks about Wolf Thornhill or Anthony Perrat or Ralph Jurgens. By comparing two Hubble Space Telescope images of the butterfly wings taken in 2009 and 20. Wait a second. Didn't they talk about 2019 here in the beginning? I think it is. Maybe it was under the picture. "19 and 20. And here we have 9 and 20. But anyway, I'm just a random dude wondering about things. Researchers have discovered strange new processes driving the nebula's growth. The team identified evidence of a half-dozen jets of intense wind blowing out of the nebula's central star, which appear to have been gusting in chaotic crisscross patterns for thousands of years. These jets, which erupted from the central star from 2,300 and 900 years ago, pushed matter toward the edges of the nebula at uncommonly high speeds, up to 500 miles, 800 kilometers per second. Yeah, just remember. Uncommon, here they mention the word uncommon. And strange new processes. So probably these aren't true as well, since they somehow tell you all the time that they don't really know. So we have to take this with a very big grain of salt. According to the researchers, meanwhile, matter located closer to the central star has been crawling outward at just 1/10 that speed, resulting in complex asymmetrical structures forming throughout the nebula's wings. The butterfly nebula is extreme for the mass, speed and complexity of its ejections from its central star, whose temperature is more than 200 times hotter than the Sun, yet is just slightly larger than Earth. Team leader Bruce Balick, a professor emeritus of astronomy at the University of Washington, said in a statement, "I've been comparing Hubble images for years, and I've never seen anything quite like it. As for the butterfly shape, that's still tricky to explain with existing models of nebula formation, according to the researchers." No, it's not. Even I know stuff about that. How comes they don't? It doesn't fit into their paradigm. It's possible that nebula's central star collided with a hidden companion star, or at least gobbed up with some extra gas from one, generating complex magnetic fields that shape the nebula's signature wings. This is just a hypothesis. However, Balick said more research is needed to explain this butterfly's metamorphosis. Yeah. Fortunately, this was rather short, but let me show you butterfly wings. Everybody should read this paper, Characteristics for the Occurrence of a High Current Sea-Pinch Aurora as Recorded in Antiquity. Anthony L. Peratt. And if we go down here we are talking about birkeland currents, electric currents in space. And I just now scroll down a little bit. You can see Jacob's ladder and stuff. Squatterman. And it depends, like these are plasma stabilities and instabilities. So their form will transmutate according to the charges and how to put it. You know, it's an alive thing. It's moving. Maybe if it's that big and we are so small as humans and just don't really get it, it seems that it doesn't move too much. Even though that I have noticed some changes in the 11 years they were recording that, or those two pictures. But it's in the end the same thing as the Squatterman. Just have to imagine this going a little bit more like that. You just need to imagine this turn 90 degrees. Our butterfly nebula. Turn it upside down or 90 degrees and you will get the same shape as we just saw in Anthony Peratt's paper. And now to something else which is rather interesting. Maybe more graspable for many, since we are talking about earthly things. For this we go over to phys.org. Surprise magma chamber growing under Mediterranean volcano. Submarine volcanic activity along a section of the Colombo crater on the seafloor observed with Santori monitoring equipment. Bubbles. Using a novel imaging technique for volcanoes that produces high-resolution pictures of seismic wave properties, a new study reveals a large, previously undetected body of mobile magma underneath Colombo, an active submarine volcano near Santorini, Greece. The presence of the magma chamber increases the chances of a future eruption, prompting the researchers to recommend real-time hazard monitoring stations near other active submarine volcanoes to improve estimations of when an eruption might likely to occur. Nearly 400 years ago. Some may notice 400-year cycle of the Sun. In 1650, Colombo breached to the surface and erupted. killing 70 people in Santorini. This eruption, not to be confused with the catastrophic Thera Santorini volcanic eruption that occurred around 1600 BCE, was triggered by growing magma reservoirs beneath the surface of Colombo. New researchers? No. Now, researchers say the molten rock in the chamber is reaching a similar volume. The study, published in Geochemistry, Geophysics, Geosystems, was the first to use full waveform inversion seismic imaging to look for changes in magmatic activity beneath the surface of submarine volcanoes along the Hellenic Arc, where Colombo is located. Full waveform inversion technology is applied to seismic profiles and recordings of the ground motions along kilometer-long lines, and assesses differences in wave velocities that may indicate subsurface anomalies. The study showed that full waveform inversion technology can be used in volcanic regions to find potential locations, size, and melt rates of mobile magma bodies. Seismic profiles were constructed after the researchers fired air gun shots from aboard a research vessel cruising over the volcanic region, triggering seismic waves that were recorded by ocean bottom seismometers located along the arc. Full waveform inversion is similar to a medical ultrasound, said M. Paulato, a volcanologist at Imperial College London, England, and second author of the study. It uses sound waves to construct an image of the underground structure of a volcano. According to the study, a significantly decreased velocity of seismic waves that travel beneath the seafloor indicates the presence of mobile magma chamber underneath Colombo. The characteristics of the wave anomalies were used to develop a better idea of the potential hazards the magma chamber may present. According to Kajetan Krapkiewicz, a geophysicist at Imperial College London, England, and lead author of the study, existing data for submarine volcanoes in the region were sparse and blurry, and the dense array of seismic profiles and full waveform inversions has allowed them to obtain much sharper images than before. These were used to identify a large magma chamber that has been growing at an average rate of roughly 4 million cubic meters per year since Columbus' last eruption in 1615 CE. 4 million cubic meters per year. The total volume of melt that has accumulated in the magma reservoir beneath Colombo is 1.4 cubic kilometers, the study found. According to Krapkiewicz, if the current rate of magma chamber growth continues, sometime in the next 150 years, Colombo could reach the 2 cubic kilometers of melt volume that was estimated to be ejected during the 1650 CE eruption. Although volcanic melt volumes can be estimated, there is no way to tell for sure when Colombo will erupt next. Preparing for submarine explosive events. The characteristics of the magmatic system at Colombo indicates a highly explosive eruption, similar but a lesser magnitude than the recent Honga Tonga Ha'apai eruption in the future, according to the study's authors. Although danger doesn't appear to be imminent, an explosion at the Colombo volcano could be more disastrous than the Tonga eruption due to its proximity to the population center of Santorini, Greece, located only 7 kilometers, 4 miles from the volcano. Colombo is found in a relatively shallow part of the Mediterranean Sea, around 500 meters deep, which according to current estimations is likely to enhance its explosivity. A tsunami and eruptive column tens of kilometers high with a large amount of ashfall are predicted to occur when Colombo erupts. Jens Carstens, a geophysicist at the Geomar Helmholtz Center for Ocean Research, Kiel, Germany, who was not involved in the study, underscored the importance of the recent findings. With studies like this, we can learn more about how volcanic structures work, what to expect and where to expect it, and can use that to design monitoring systems for underwater volcanoes. Tell you what, if you see clouds or weather system hanging around over the sea, you can bet there is something going on under the sea surface, hence in the ground. Hence probably some magmatic intrusions or whatever electromagnetic things are going on. There is, big contradictions in weather forecasting and such things like that. But anyway, the study adds to the growing knowledge base of Colombo, the most active submarine volcano in the Mediterranean, and the hazards it poses. According to the researchers, full waveform inversion technology can be used to identify similar magma reservoirs hiding beneath other active submarine volcanoes, but it can be a spatially restrictive and time-consuming process that would be best used in combination with other techniques, such as volcanic sediment drilling and seismographic monitoring, to help form a better idea of what's really going on under submarine volcanoes. Over the last several years, an international team of scientists has been working on establishing Santorini's Seafloor Volcanic Observatory, or Santori, a seafloor observatory outfitted with scientific instruments that will be able to measure progressions in Colombo's volcanic activity. Santori is still under development, but according to Krapkiewicz, it is a good example of what a submarine volcanic monitoring station can potentially look like. As Paolotto points out, there are more land-based monitoring stations for continental volcanoes than there are for submarine volcanoes. Haha, what a surprise. Monitoring volcanic activity underneath the ocean surface is more complicated and expensive than it is on land. However, we have satellite images. Watch the clouds. I really watch them. Think about how weather works. It's an electrical phenomenon. If there's something going on in the sea floor, it will reflect in the sky above. It's just so. Everything is connected. There are no islands in space. Bad weather underneath means bad weather above. And this doesn't mean high pressure are good or low pressures are bad. It's always depending on the things. But anyway, the researchers hope that this study, in combination with the data collected by Santori and the International Ocean Discovery Program Expedition 398 sediment drilling crews, will help convince policymakers of the critical importance for real-time monitoring stations on submarine volcanoes. Convince. They won't believe. We need better data on what's actually beneath these volcanoes, Krapkiewicz said. Continuous monitoring system would allow us to have a better estimation of when an eruption might occur. With these systems, we would likely know about an eruption a few days before it happens, and people would be able to be evacuated and stay safe. Yes. I just wanted to show you these two things. Let's go back to the start. There could be now made some own research about where is Colombo exactly and all these kind of things, but I won't do that because it would be an endless video once again. So I think I'll leave it here. You can read the whole articles and stuff on your own pace. I just wanted to provide you the information, and it's totally 100% up to you. What do you do with it, if anything? It's up to you. It's not my business. But anyway, stay curious and motivated. Keep your shit together. Thanks.